Welcome to yet another session of Narrowband Internet of Things. This is the fourth video of this series. Thank you for your support and then continue to watching these videos. In this video, we will talk about network coverage and SIM cards. A key element in an IoT device powered by cellular technology is its SIM card. The SIM card handles authentication and registration of our UE, that is user equipment, to the network through a service provider, either a mobile network operator or a mobile virtual network operator. Therefore, it is important to understand the differences in service between different service providers and different regions and the difference between roaming and local use SIM cards. Just like regular cellular services we use every day, cellular IoT technologies are also subject to the service provider. It is not guaranteed that what works in a certain region or country will work in others. This depends on a list of factors like whether LTE-M and NB-IoT have been deployed in that area, what the coverage is like, what your SIM card supports, and what the service provider you are using supports. Network coverage. The GSMA, Global System for Mobile Communication Association, created a mobile IoT deployment map which lists the deployment of LTE-M and NB-IoT in a country-by-country basis. The map shows which countries support LTE-M, which countries support NB-IoT, which countries support both, and which countries support neither. It is worthwhile to check the map and make sure that the country you intend to deploy your application in is covered by the needed cellular IoT technology. Although the deployment map depicts coverage over a whole country, the coverage can also vary by region within the country. Therefore, you need to check whether the specific network operator operating in that area to get a more detailed coverage map. SIM card. The type of coverage and subscription you will get depends on your SIM card and the service provider you bought it from. It is important to note that the type of SIM card you need is usually different from the SIM card used for communication between cell phones. Roaming SIM cards are designed to be used anywhere where the SIM card provider has a roaming agreement with the local service providers, giving the user ease of mobility. NRF 9160 SIP. NRF 910 system in package is Nordic cellular IoT solution supporting both the LTE-M and NB-IoT. The NRF 9160 SIP consists of an application processor, an LTE modem, an RF front end, a PMC, that is power management IC, passive components, and crystal oscillators. In addition, you need a power source, typically a battery, an eSIM, and an LTE antenna. You can also add a dedicated GPS antenna and sensors. Nordic Semiconductor provides modem firmware binaries to operate the LTE modem and the NRF Connect SDK as a tool to develop the application, which will run on the application core and interface with the modem. This course will focus mainly on application development for the application core and how to interface with the LTE modem using the available libraries in the NRF Connect SDK. NRF 910 SIP architecture. This SIP is powered by a battery, and then you can connect various sensors to the SIP. You can connect a SIM card also, and then you need two antennas, one for GPS and one for LTE. And apart from that, NRF 910 SoC contains ARM Cortex core, and then required memories, flash memories, and then all communication ports like I2C, SPI, UART, etc. The application processor runs your application while the modem runs modem firmware provided by the Nordic as pre-compiled binaries. NRF Connect SDK contains the modem library which the application will use to interface with the LTE modem. The application processor on the NRF 9160 SIP is an ARM Cortex M33 MCU with ARM Trust Zone technology. This is relevant because the trust zone technology enables the separation of a secure and non-secure domain. Cortex M33 application MCU. It has a bootloader chain, then trusted firmware. Both belong to secure domain, and then application area, modem library. They sit in non-secure domain, and then they connect to LTE modem. At boot up, the application always starts execution from the secure domain. From there, the trusted firmware M is started, which will configure part of the memory as peripherals as non-secure and then jump to the main application in the non-secure area. This is all automated by the NRF Connect SDK when building your application for the non-secure domain. You can see from the figure the modem library which interfaces with the LTE modem is defined in the non-secure domain. Therefore, when building for the NRF 9160, you should always build for the non-secure domain. The application layer is the topmost layer, and then behind them you have various communication protocols like HTTP, MQTT, COAP, etc. And then it has AT commands, buttons and LEDs, link controller. Then below that is a modem library, and then below them is IPC and shared memory. TLS, DTLS are security protocols, where TCP and UDP are communication protocols. IPv4, IPv6 depends upon the cellular service provider. And then these all black layer consists of modem firmware, and then below that you have the physical layer. Communication stack. Below is an illustration of the NRF 906 SAP communication stack. Throughout this course, we will cover different layers and refer back to this diagram. The modem firmware is running on the modem core of the NRF 960 SAP and is provided as a binary. The interface with the modem, we have the modem library. On top of there sits all the drivers, subsystems and libraries available in the NRF Connect SDK, and at the top is for cellular application. Let us conclude this video with this part, and let us meet again once again in another video which will continue to explain the NB-IoT. Till then, see you. Tata. Bye bye.